Hey, welcome back. Today we're going to be doing LeetCode problem 226, inverting a binary tree. Now a binary tree is a little bit different data structure than what we've seen in the past, but with that being said, let's go ahead and jump into it and we can walk through it together. Also, if you haven't liked or subscribed to this channel, go ahead and do so. It really helps me out. All right, let's get going. Okay, let's go ahead and get started by reading the problem statement and going through some examples. Given the root of a binary tree, invert the tree and return its root. So we have here 4, and that's its root, and then we have some children here. So the children to the left is 2, and the children to the right is 7. Now these also have some children. So root.left is 2, and 2 has 2 children associated with it, 1 and 3. 7 has 6 and 9. Now you can see here in this first problem statement, what we're wanting to do is we're wanting to invert it. So 2 now becomes 7, and 7 now becomes 2. Well, what about the children of those? Well, 6 now becomes 9, and 9 now becomes 6, 1 becomes 3, and 3 becomes 1. Now, if we go down and we read the second problem statement, or the second example, 2 has the children of 1 and 3. Inverted 2 is 3 and 1. So, okay, I think we're kind of getting an example here. We're kind of getting an idea of what we need to do. If root is equal to null or is an empty array, it's not an empty array. If it's an empty binary tree, then that's our base case. We need to return null. Let's go ahead and take a look at our examples. Binary trees are kind of like linked lists, but they have a left and right pointer. You can see that up here as well too. What we need to do to figure this out is we need to keep memory of either a left or right. Then we need to switch the left and right pointers. And then we need to recurse through the root until we've hit null. So we can already tell here that null is going to be our base case. So if root does not exist or is a null value, we're going to return null. Now in recursion, you always want a base case, and this is going to be our base case. If root is equal to null, we're going to return out of it. So I've written down some examples here. We have 4, 2, 7, 1, 3, 6, and 9. Now you can see here in the first inversion, we're actually moving 7 and 2, and we're moving all of its children with it. You can see here 7, 6, and 9, 2, 1, and 3. So that's going to be the first inversion. The second and subsequent inversions are going to be 9, 6, 3, and 1. And we're going to keep doing that all the way until we get to null. And then we're going to come back up, and then we're going to hit our root. All right, so let's go ahead and write that out. How do we do this? Well, what we want to do is we want to keep memory of our next pointer, or our right pointer. So what I'm doing here is I'm keeping memory of 7 in a variable. And then what I'm going to do here is I'm going to say root.right is equal to root.previous. I'm sorry, root.left. You can see I'm used to linked lists, so that's why I keep writing previous and next, but actually it's right and left. So root.right is now equal to root.left, and that's why we have a memory. So now root.left needs to equal memory, what the original value of right was. And then what we're going to do is we're going to do some recursion. So recursion now is going to say invert tree of root.right, because we want to go down to that next root, and we want to keep going again until we hit null. So we're going to recurse through root.right, and we're going to say revert tree root.left. And at the very end, we want to return our root, because now our root is going to be inverted, right? So let's go ahead and run this. And perfect. We have a clear inverted binary tree. Let's go ahead and submit this. And that's it. We hit 45 milliseconds and 42 megabytes. Alrighty, folks, I hope that clears some up for you. Again, if you haven't liked or subscribed, go ahead and do so. That really helps me out. And without further ado, I hope you have a great day and a great rest of your week.